should have switched this on so it could have warmed up. So what I'm going to do is I'll just create a main in cpp.sh, and inside of the function I'm going to create a stack, an array of, let's say, 1,000,000 elements. We'll compile it and we'll see that it actually doesn't work because it'll say, not enough memory or something like that. Even though my computer has, 16 gig of RAM, if I have a massive array in stack, it's not going to work. It'll say, no, I don't have enough memory. However, I can then turn it into an array on the heap and it'll all work beautifully. So that's HTML. Oh, it is on HTML. Oh, there it is. Okay, so this is my main. Let me go ahead and here I'm going to say I want a stack. I want to. Let me do namespace also. Right. Okay, this is easier. All right, now I'd say int stack of ints. Okay, stack of int of 1,000,000. Right. So let's see if I can get a stack of 1,000,000 integers. Let me assign stack of int of let's say 1,000,000 minus 10. Okay. So I'm going to the last, but 10th element from the end and assigning it the value 5. Right. Let's see if this works. And then cout. Oh, my indentation. Cout the element of interest is stack of int of 1,000,000. Does anybody know why I do this instead of saying, if I could say 1,000,000 like this, right? I could say 1,000,000 like this. Yeah, this is also 1,000,000, but I don't say it like that. I say it like this. What does can you guess why I would do that, Christopher?
Like the number, like 1,000,000 would be too big for the type in to handle.
No, but if that's the case, even this would not be. If that's the case, even this wouldn't work, right? Because I calculate 1,000,000 there, right? And it's still going to be too big, right? So no, but by the way, 1,000,000 is not too big, right? Because in modern computers, an int is like 4 bytes. It's like 4 billion. So why do I say 1,000 times 1,000 instead of 1? Because humans are notoriously bad at reading successive, same thing, right? So if you go to a forum, like if you go to Fortnite forums and try to flame some person, right? Saying, hey, that guy took my, balloon axe or something like that. Okay, right? So you flame that person, and you don't want that person to come back and flame you back, right? Hey, no, what the hell are you doing playing Fortnite in my arena? Get the, hell out of here. All right? So, so you don't want the flame war to happen. What people do, what people do, right? You've been on these forums. They'll say, they'll create a name like this. They'll say, comment. So user 1000000, 1L, no, L1, L1, capital I. Okay, that's my avatar name. I can have an avatar name like that, and go and flame someone. And most people can't even figure out what my avatar is because they can figure out which one's a 1, which one's a capital L, which one's a capital I, which one's a 0, which one's an O. So by the time they figure out who you are and report you to the moderator, you could have moved on, right? So you can pick these. So humans are very bad at counting these things, and so you can be kind to your fellow programmer by saying, I don't mean you don't have to count the number of zeros to see that it's 1,000,000. It's actually 1,000 times 1,000. When a fellow programmer sees that, they'll know exactly it's 1,000,000, right? They don't have to count. And you can say, it's only going to be a couple of milliseconds. Most people can look at it and say, oh, it's times they can count the zeros in a couple of milliseconds. No, that's not the right attitude, right? Always be kind, because a couple of milliseconds is still driving at 70 miles an hour, and then just hitting the brake, and then that sound, that little feeling when you stammer on the that you can save programmers that, and you'll appreciate that when you become experienced programmers. Beginners don't appreciate that because beginners are all, most of the time when they're coding, they're always pausing every step to see, am I doing it right? Am I doing it right? Right? Are you doing that? So, or even if you write a little fragment, you'll say, oh, is it right? You're going to check, you're going to debug. But when you get more experience, you'll be writing bigger and bigger chunks before you go to testing it. And when you're doing that, it is really, really annoying if you have to stop and check at every step, right? Especially for little things like this. So you can make it easier by just saying 1,000 times 1,000 instead of, and you don't have to worry that by saying that, oh, I'm increasing compute load, at compute time it's going to do some extra calculation to get the value. No, you don't have to worry about that because today compilers are so intelligent. Well, what today? Even 10 years ago. When I studied compilers, we were already optimizing this, right? This was like 15 years ago. So we were already optimized. The compiler looks at these things and says, well, that's a constant quantity. It doesn't need to be recomputed at runtime. I'll just plonk in the value 1 million even though the user said that 1,000 times 1,000, right? So the compiler doesn't even see this, and sometimes it just gets replaced before it translates the code into machine code. So you don't have to worry about optimization. Don Knuth, I think he became famous for saying this, but he himself says, I didn't come up with this. Tony Hoare came up with this statement. It's called premature optimization is the root of all evil, right? It's a famous statement in computer science, made famous by Don Knuth, but it has a lot of sense because what it says is premature optimization is, you write a program and immediately you start thinking, okay, I want to make it as fast as possible, and you start tweaking things here and there and shaving off a few compute cycles here and there. Most of the time, 99.9% of the time, you're optimizing useless shit. Right? Because what happens is that you've got a program, you don't know which part of the program gets executed most often. Which part of the program is not, touched once, maybe once a day or something like that. So, but there are tools available with modern IDEs that let you find out. It's called a profiling tool. When you write a program, you can profile your program, and the profiler will run your program as though it's in the real world, and then it'll keep count. It'll keep count of the number of times each function is being entered. It'll keep count of the number of seconds spent in each function. And then at the end, it'll tell you, right, you have a program that is 10 million lines of code, and you profiled it, and when you start working, you'll see this, right? People will say, I'm going to make this program faster. I'm going to make this program faster. They'll come in and take these chunks of code and try to optimize them. The inexperienced programmers will take chunks of code before they have been profiled, before the code has been profiled, right? So it becomes a case of, you've heard this old story, right? So King Solomon times when he was visiting one country from another, maybe Israel, right? And so he was packing up, all the stuff, and his servants had to carry the load, big load, right? So they said, and they get the choice of saying, I want this to carry, I want that to carry. So one guy said, we went for the biggest possible thing that he had to carry. I'll bring that. Another person said, I'm going to take a small box, I'm going to carry that. And they went along. But as they went to this other country traveling, they found that the small container was basically the container where the King David or whoever it is, would buy things or get gifts and put it in there, right? So it kept getting bigger and bigger. So as the journey progressed, the guy with the small box started getting more and more things to carry. Whereas the big box guy was carrying food for the entire army, right? So as the journey progressed, the food got eaten and it got smaller and smaller. So likewise, optimization, when you have this big code base and you need to optimize it, before profiling, lots of people say, hey, you know what? This code, in the billion lines of code, this chunk looks like it's going to take up a lot of computing because that's like 20% of the entire code base is that chunk. I'm going to optimize that, right? But someone else would say, let me profile the code first. And they profile the code, and out of the profiler comes the output that says, of the billion lines of code, there are these 3 lines in this function. Just 3 lines in a function of 3 lines that gets called every second or every millisecond that function is called. But it's only 3 lines, right? Whereas you have, 20,000 lines of code, which could potentially have, great scope for optimization. You can thin it down, you can make it really fast. Maybe it's really inefficient, right? It's screaming out for optimization. It needs to be optimized, and it's a large code base, but it's only called once per week, right? So which one would you optimize to get, the profiler says, Don't optimize that big code, because that's only getting called once a week. Most of your program's execution time, when it's running, is spent in these 3 lines of code. So you go in and look at the 3 lines and say, my gosh, these 3 lines, it's doing linear search instead of binary. If I do binary, I can cut down the lookup time from 1 billion to, let's say, 6, or something like that. And you make that change, and instantly your code, so because you know exactly where to go, what to change. And that's how profiling works. And these experts that come in, the consultants that are brought in, they look at your code, they look at your design and say, well, it's a massive system, right? And they say, well, I've done it. And they take a whole month maybe to look at your system. You get people from Accenture or some, these analysts, and they look at your code. They say, and you ask them, have you come to a conclusion about what we can do to improve? They say, no, one month. So they take a lot of time to look at your code, and finally one day they come back and say, well, here's your big system. We've looked at it, and this thing here, like 2 lines, that's what you need to optimize, right? So, and you say, well, that you're billing me like $500,000, $500,000 just to be able to tell me that these 3 lines need to be changed. But that's what it is. All the effort was not for the 3 lines; it was for identifying that those were the 3 lines that needed change out of 1 billion lines, right? If you didn't have the expertise to go in like that and do the profiling of your code and do that, you'd be stuck. You'd be optimizing all useless things here and there, trying to say, why isn't it speeding up my program? I changed that. I made that from cubic to linear, and it's not making a difference in my program, right? And you keep asking yourself these questions. That's only because you profile the code. Anyway, so coming back here, so we have a massive stack. Let's see if this works, okay? So that's why I have this. Okay. Oh, and oh.
It should be minus 10.
Sorry?